This is another example of a geometric proof involving triangles. On this one, you've got some overlapping triangles, triangle MTP and triangle NSR. And you're given some information about that. And so we're going to do a two-column proof here. And so we just plug that into the given. Just for time's sake, I'm not going to write that out, but you should always write out what your given statement is. And then I need to look and see what do these given statements give me. And if you've got MT parallel to NS, then we should be looking for angles that are congruent or supplementary. Similarly, since we have MP congruent to NR, we should be looking for angles that are congruent or supplementary. You need to have a common transversal for this to happen. So for instance, we would know that T is congruent to angle NSP because those are corresponding angles, and when lines are parallel, corresponding angles are congruent. And for the exact same reason, we know those are congruent to each other. Now we also know that this angle is congruent to this angle by corresponding angles, which would also be congruent to this angle, but in this particular problem, it isn't actually necessary. It is a way to show M congruent to N if you needed to, but we're not going to need that, so we're going to leave that out for now. Your goal is to show TS congruent to PR, which if you've done enough of these proofs, you know that we're probably going to use some segment addition to do that. So we start off by, after writing that given statement in, we start off by making the claims I just said, which would be MTS congruent to NSP or in angle NSR, and then for the exact same reason, we're going to say MPT congruent to NRP or NRS, however you want to say it. Okay, so we've got these two sets of congruent angles, and for both of those, it's the corresponding angles are congruent, and we can only do those because we have these parallel line statements. We're taking those directly from the parallel line statements. And then you're also given that MP is congruent to NR, and so if you pull these triangles apart and look closely at them, right, we just separated those out. You're given MP congruent to NR. We just showed T is congruent to S and P is congruent to R, which if you know your triangle theorems well, that's enough to show that the two triangles are congruent by angle side. So we'll say triangle MTP is congruent to triangle, and we've got to go the same order. So it's got to be NSR. And for us, we have angle side. So angle side is our reason. So now I've shown that MPT is congruent to NSR, and that was valuable because now, using CPCTC, I can show that TP is congruent to SR. That's our CPCTC. And so now I've shown that this is congruent to this. And if I can cancel out the SP, then I know that I'm in good shape, and I can do this problem. To do that, I'm going to have to use segment addition, and so I know that I'm going to need to go ahead and write TP equals SR by definition of congruent segments, and I know that because I'm going to be doing some substitution to show that those two are equal. And you can't do substitution on congruences. You can only do them on equality, so that's why we've got to write it out as an equality. So now we just go through and perform the segment addition. That says TS plus SP equals TP, and SP plus PR equals SR. That's just basic segment addition. It's just a segment addition postulate. It's just saying that this length plus this length equals the total length TP, and then SP plus PR similarly equals SR. Now we do a substitution. Since this equals TS plus SP, we can plug that in for this. And then since this equals SP plus PR, we can plug it in for that. And that's just by substitution. And then, because these both have SPs, we can cancel those SPs out by subtracting them away to get TS equals our PR and that is by the subtraction property of equality. And then finally, we can say that TS is congruent, and we can make it RP instead of PR because it doesn't matter, and that's just by definition of congruent segments. So that's a way to go through and do this proof. A lot of times these overlapping, it's very helpful to redraw the picture separating the two overlapping triangles apart from each other.